for set A, a galvanic cell consists of a magnesium electrode immersed in 1.0 m magnesium nitrate solution and a silver electrode immersed in 1.0 m silver nitrate solution. The two half cells were connected by a salt bridge. Draw and label a cell diagram for the above galvanic cell. So first, we know that magnesium is Mg, magnesium nitrate solution is MgNO32, silver is Ag, and silver nitrate solution is AgNO3. So since the question asks us to draw and label for galvanic cell, we know that galvanic cell consists of electrodes in two different containers. So before labeling, we need to determine which one is cathode and which one is anode by referring to the E0 values given. So the E0 values given for Mg is negative 2.37, while the E0 value given for Ag is positive 0.8. So as we can see, the E0 value of Ag is more positive than the E0 value of Mg. So the Ag would be the cathode and the Mg would be the anode. So we know that electron flow from cathode to anode, right? So that's why the Ag would be on the right side and the Mg would be on the left side. So the salt bridge contains a salt, for example, KCl. KCl will dissociate into its ion, which are K plus and Cl negative. So the Cl negative would move towards the anode to balance the positive charge accumulating there due to Mg2 plus ions entering the solution, while the K plus would move towards the cathode to balance the negative charge due to Ag plus ions being reduced and leaving the solution. Moving on to question B, write the cell notation. To write the cell notation, we need to remember the arrangement to write the cell notation. So to make it easier to remember, we use the ABC method, where the A represents anode, B represents the bridge, and C represents the cathode. So now the anode is Mg, right? So we just write it back down. So the sequence must be anode electrode, anode electrolyte, cathode electrolyte, and cathode electrode. Write the half cell equations and the overall cell reaction equation. By referring back to the label diagram in question A, we can see that cathode half cell undergoes oxidation as it loses electron, while anode half cell undergoes reduction as it gains electrons. So, to write the half equations, we need to remember that anode gain electron, so the electron would be on the right side of the arrow. So the equation would be Mg arrow Mg2 plus 2 electron. While for cathode, it loses electron. Electron will be on the left side of the arrow. So it will be Ag plus 2 electron, arrow Ag. Now for the overall cell reaction equation, we just need to cancel out the electrons since it is already balanced and write back what is remain. So the answer would be Mg plus 2Ag plus arrow 2Ag plus Mg2 plus. Moving on to question D, calculate the standard cell potential. To calculate the standard cell potential, we need to remember the formula. E0 cell equals to E0 cathode minus E0 anode. So we already know that cathode is Ag and anode is Mg, right? So we just need to substitute back the given E0 values. Okay, so you will get positive 0.80 minus negative 2.37, and the answer would be positive 3.17 V. Lastly, state the oxidizing agent and reducing agent. So based on the half equations that we wrote, we can see that the oxidation number of anode increases from 0 to 2 plus, while oxidation number for cathode decreases from 2 plus to 0. So this is also another proof where anode undergoes oxidation and act as reducing agent, while cathode undergoes reduction and act as oxidizing agent. So the final answer would be oxidizing agent is Ag plus, while reducing agent is Mg.